Hi everyone, I'm going to show you guys of how to find the eigenvectors and eigenvalues for this question. So it's a 3 by 3 matrix. So your first step, let's write the matrix down. Let's see. So what you do first is you subtract this with lambda into the identity matrix. That's the rule. So 0, minus 1, 3, minus 1, 4, 1, 3, minus 1, 0, subtracted by lambda 1, 0, 0, 0, 1, 0, 0, 0, 1. That gives you 0. So let me just write it again. 0, minus 1, 3, minus 1, 4, 1, 3, minus 1, 0. Sorry, this is minus 1, 2. Minus lambda 0, 0, 0, lambda 0, 0, 0, lambda. Then just multiply. Hey, I took lambda inside. Okay. Now let's subtract. It's a 3 by 3 matrix. Both of them are 3 by 3 matrix. So it's just minus lambda minus 1, 3. Then minus 1, 4 minus lambda minus 1. And 3 minus 1 minus lambda. This is your matrix. And now you have to find the determinant for this matrix. And the determinant should be equal to 0. And that's how you find your that's how you find the value for lambda. So those values are going to be your eigenvalues. Okay. So how we do that is, so how do you find the determinant? You cross the first row and the first column, then you end up with 4 numbers, right? So it's going to be minus lambda into 4 minus lambda into minus lambda minus 1 into minus 1 is 1. And minus, it's going to be minus all the time, okay? So minus into, can we focus on this number? Minus 1. Gotta write that below, okay? I hope you guys don't get confused. Just tell me if you guys are confused with the way I'm doing. I'll just make a new video. I just don't have enough space on the page. So minus 1 into. So now you cross the first row and the second column. And then you end up with, see, you can see, right? Minus 1, 3, and left. So it's going to be minus 1 into minus 1 into minus lambda minus 3 into minus 1 plus your final step 3 plus 3. Look at this number. So you're crossing the first row and the third column, giving you minus 1 into minus 1 minus 3 into 4 minus lambda. It's like this. First these two get multiplied, then you subtract it with these two. It's like that. This whole thing equals to 0. Okay, so we got 4 minus lambda. Let's just expand it. So we have lambda squared minus 4 lambda minus 1. This into minus lambda and minus 1 into lambda plus 3 plus 3 into 1 minus 12 plus 3 lambda equals to 0. So now we can expand the brackets again. So we have minus lambda cubed plus 4 lambda squared plus lambda minus lambda minus 3 plus 3 minus 36 plus 9 lambda equals to 0. You can cancel off this lambda, you can cancel off 3, and you end up with minus lambda cubed plus 4 lambda squared plus 9 lambda minus 36 equals to 0. So I'm going to take everything over to the other side. Let me just recheck again, because the chances of making mistakes are very high because you have so many brackets and stuff. So let me just recheck again. Oh yeah, I did make a small mistake. So here you can see it's minus into minus 1, right? So this has to be plus 1. That becomes plus 1, so these don't cancel out. You have to recheck all the time. So this is plus lambda, and this is plus 3 here. So now I'll rewrite it again. So this one did get still 1 lambda minus 30. Now I'm going to take everything on the other side. Okay, now we have to solve this polynomial. Okay. Let me show you guys of how to do that. So we can do this using trial and error method, but you can do it like that. Or you could also use your calculator, but for depend. I think the Edexcel exams allow this Casio calculator, so you can use the calculator to find the answers, but you have to show the method of how you got it. So I'll just show you guys of how to divide a polynomial using a factor. So when finding a factor, I want to show you guys of a simple trick you guys can use. So look at the last number you guys have here, okay? The last number, and look at the coefficient of the highest power. So you divide the last number with the coefficient of the highest power, which is 30, right? So in this case, it's the same thing. Let's say it was 2 in front of the highest power, then it's 30 divided by 2, 15, right? So in this case, it's 30. And now look at the factors of 30. So what gives you 30? You can write this as 2 into 15, and this as 3 into 5, right? So you can write 30 as 2 into 3 into 5, right? So 2, 3, 5 are the factors of 30. So what you can do with 2, 3, 5 is you select the smallest number, okay? You substitute 2 into lambda and see whether you get 0. If you get 0, then 2 is a factor. Always go for the smallest value, right? So if 2 doesn't work, try minus 2. Because that might work too. So let's try 2, okay? So 2 cubed minus 4, 2 squared minus 11 into 2 plus 30. So you put this in your calculator. So 2 cubed minus 4 into 2 squared minus 22 plus 30. And that's 0, see. Therefore, 2 is a factor. So you can say lambda minus 2 is a factor. Now, I'll write down the polynomial. Okay. So now let's divide. So you divide every term with lambda, and then you multiply it again. So lambda cubed divided by lambda is lambda squared. Lambda squared into lambda is lambda cubed, and lambda squared into minus 2 is minus 2 lambda squared. Now you have to subtract the 2 to get the remainder. So minus 4 lambda squared minus 2 lambda squared. So that's minus 2 lambda squared, right? Minus 4 lambda squared minus, open brackets, minus 2 lambda squared, close brackets. You subtract those. So you get And this minus limit comes down, minus 7 lambda. Now we divide minus 2 lambda by lambda, which is minus 2 lambda. And minus 2 lambda into lambda is minus 2 lambda squared. Minus 2 lambda into minus 2 is plus 4 lambda. And then you subtract these again, minus 11 lambda minus 4 lambda, giving you minus 15 lambda. Now you can take this 30 down, plus 30. Now we divide 15 lambda by lambda, minus 15 lambda. So it's minus 15 into lambda, which is minus 15 lambda. And minus 15 into minus 2 is plus 30. So you can see 30 minus 30 is 0. See, the remainder is 0, perfectly divided. So lambda minus 2 into lambda squared minus 2 lambda minus 15 will give you this polynomial. Okay? So now we factorize lambda squared minus 2 lambda minus 15 equals 0. We have to find the factors of this. So what factors of 15 gives minus 2? Minus 5 and 3, right? So you can write lambda squared minus 5 lambda plus 3 lambda minus 50 equals 0. You can take lambda out. Lambda minus 5 plus 3, lambda minus 5, 0, lambda minus 5 into lambda minus 3. So lambda plus 2. So your factors are lambda minus 2, lambda minus 4, minus 5, lambda plus 3. So your answers go in order, okay? So it's minus 3, 2, and 5. These are your eigenvalues. All right? And now to find your eigenvectors, what you do is you have to write, I'll take this down because I don't want to write the matrix again. Because I tend to make a mistake when writing the matrix again with either a symbol or whatever. So I'm just going to take the matrix down here and write the same thing we had earlier. Lambda 0, 0, 0, 0, 0, 0, lambda. Okay. So now what you do is you have to put your eigenvalues into all of this. Instead of lambda, you put your eigenvalues. And then you find your eigenvectors. I'll show you. So 0. So we had something else. We wrote that down as, yeah, I think so it's minus lambda minus 1, 3, minus 1, 4 minus lambda minus 1, 3, minus 1, minus lambda, right? So let's put in minus 3 first. So, and it's like this, okay? So when finding your eigenvectors, you have to select. So we can select, it's like this. You either select, that means you can select 2 rows. So you can select these 2 rows, or you can select these 2 rows, or you can select the first row and the third row, any way you like. But usually the way I do is I select the first row and the second row. Then we find the cross product. It's actually an easy method. So instead of writing all 3 rows, I will write the first 2 rows. So minus lambda, minus 1, 3, minus 1, 4 minus lambda, and minus 1. So here it is. So you substitute minus 3, giving you 3, minus 1, 3, minus 1, 4 minus 3, 7, minus 1. So what you do is you write I, J, K, 3 minus 1, 3, minus 1, 7, minus 1. So now so this is the cross product, right? So you cross the first row and the first column, you end up with these values. So it's I into 1 minus 21 minus j into minus 3 minus 3 plus k into 21 minus 1. So this gives you minus 20i. This is 0g. 0, right? You can see it's minus 3 plus 3 is 0. Plus 21k. So you can see you can write minus 20, 0, 21. So 20. So now you can see 20 is common, right? You can divide every term by 20. So one eigenvector is going to be minus 1, 0, 1. Divide every term by 20. So this is 1. So for eigenvalue minus 3, it's 1, minus 1, 0, 1. If you want another answer for this, you can divide every term by minus 1 too. So you can write this 1, 0, minus 1. That's also correct, all right? Both answers are acceptable. So you can write this is for lambda equals minus 3. So now let's do it for lambda equals 2. Same way, I'll take this section down. So let's put in 2 now. This time minus 2, minus 1, 3, minus 1, 4 minus 2 is 2, minus 1. With I, J, K. Same way now. I into 1 minus 6 minus J. 2 minus 3 plus K minus 4 minus 1. This gives you minus 5i minus 5j minus 5k. So you can write minus 5 minus 5 minus 5. So you can see minus 5 is common. You can divide every term by minus 5. So it's 1, 1, 1. This is your eigenvector for lambda equals 2. Easy, right? And finally, we have lambda equals 5. So let me just take this part again. So you put 5. So it's minus 5, minus 1, 3, minus 1. 4 minus 5 is minus 1, minus 1. I, J, K. I into 1 minus 3 minus K. So, oh my God, what am I doing? Minus G. 5 minus 3 plus K, which is 5 minus 1. So this gives you 4i minus 8g plus 4k. So you can write this as 4 minus 8, 4. Now you can see 4 is common. So it's 1 minus 2, 1. This is your eigenvector for lambda equals 5. That is how we do it. Okay, so I want to show you something else. So matrix n equals to d, sorry, p d to the power n p inverse. So this formula is used. So we had this matrix, right? We had this matrix. So if you want to, let's say m squared, m to the power 3. So let's say you needed to find this matrix multiplied itself by 2, try like this squared, this matrix to the power 3. Let's say it was multiplied by itself for 3 times, 4 times. So when it's a long process, right? To save up time, this is why we find eigenvalues and eigenvectors. So apart from this, if they ask, what is the diagonal vector? Sorry, diagonal matrix. Diagonal matrix. So D comes in the format like this. Lambda 1, 0, 0. Lambda 2, 0, 0, 0. Lambda 3. So 3 different values of lambda. I forgot to put the values for lambda. So lambda 1, 2, and 3. Okay. So go from smallest to biggest. So it's minus 3, 0, 0, 0, 2, 0, 0, 0, 5. That's your diagonal matrix, all right? And for P is your eigenvectors lined up together. So what you can write is, so if you went according to this order, you can see minus 3 first, 2 second, 5 third, right? So you go, you put in the eigenvectors in that same order. So for minus 3, we had eigenvector 1, 0, minus 1. 1, 0, minus 1. And for 2, we had 1, 1, 1. 1, 1, 1. And for 5, we had 1, minus 2, 1. 1, minus 2, 1. And that is P. And P inverse is the inverse of this, okay? So we don't need to find that for this. So apart from that, that's how you do the questions. If they ask you of what the diagonal matrix and P is, okay? So that's how you do. So that everything for this question. If you guys have any doubts, just drop them in the comment section. I hope you guys liked it. If you guys like my teaching, leave a like and subscribe. Have a great day. Thank you so much.